Let's look at the area and perimeter of triangles. The first thing we're going to talk about is perimeter. And remember, perimeter is just the outside edge. So to find the perimeter, you would add those three sides together. And often you need to use the theorem of Pythagoras, which says hypotenuse squared equals side 1 squared plus side 2 squared. And that's because of Pythag. Remember to write your reason. The area, however, is everything inside of those lines. So that would be the area of this triangle. Right, a very important part of the triangle is the right angle, because the right angle points to the hypotenuse. And remember, if I have a right angle on the left, I have a right angle on the right, because 90 plus 90 is 180 adjacent angles on a straight line. So that is also a hypotenuse. That is the hypotenuse in this triangle. And the other hypotenuse is in this triangle. Right, that is the first thing. But when we are doing area, I always like to say that whatever two sides this right angle grabs, so in other words, it's connecting to this and it's connecting to that. So one is the base, so we will call that the base, and this is the perpendicular height. Now remember, it doesn't matter where you move this, you will see that the height is constant. And we need to be aware of that concept when we do triangles that have an obtuse angle. So let's look at the worked example. We have to find the perimeter and the area of the triangle below. So I have to find out, so my perimeter is going to be that line plus that line plus that line. And as you can see, we only have the 7 centimeters in that triangle. Right, so what I'm going to do, I am going to have to find these two lines, and we're going to start with this line because it is the hypotenuse in the little triangle. So although these lines should be dotted lines, we always make them dotted lines because they're not part of the triangle, but we use their measurements. Right, so I can say, so Pythagoras says hypotenuse squared equals side 1 squared plus side 2 squared. My hypotenuse I don't have, so I'm going to call it x. So x squared equals, side 1 I'm going to take it 5 squared, plus side 2 is 12 squared. So x squared equals 25 plus 144. If I add them together, so x squared equals 169. To get rid of a square, I have to square root. And if I square root on the left, I'm a square root on the right. And x will equal 13, and these are centimeters. So this line here is 13 centimeters. To continue with my perimeter, I now have to find this hypotenuse. I cannot use this triangle here, so I have to use the large triangle. So I'm going to use this triangle like that. And again, I'm going to do Pythag. Don't forget your reason, Pythag. Okay, so I'm going to call my hypotenuse y this time. And remember, I'm looking at the length of this whole line here, which is going to be 12 centimeters. So hypotenuse squared, so it's y squared equals 12 squared plus the other 12 squared. So y squared equals 144 plus 144, and if I add them together, I get 288. So 288. To get rid of my square, I have to square root. And if I square root left, I'm a square root right. So y will equal, take out your calculator, and it's going to be 16,97, and these are centimeters. I then would go and write my 16,97 centimeters on my diagram. Now I'm ready and set to do the perimeter. So perimeter is going to be 16,97 plus 12, sorry, not 12, plus 7 plus 13 plus, pardon me, plus 13. And if I add those together, I will get 36,97 centimeters. Don't forget your units, and remember this is one-dimensional. It is the outer edge, so actually there is an invisible one over there. Right, now we need to find the area of the triangle. So area, you always write down your formula. Area equals half base times perpendicular height, or base times perpendicular height over 2. Area equals half. My base, this is my base in the triangle, so half times 7 times my perpendicular height, which is 12, and that would give me area equals 7 12s are 84 times a half will give you 42 centimeters. They are squared because this is two-dimensional. Area is two-dimensional. I would like you to do the test your understanding. If you're skipping that, there is practice with exercise 4.3.